Good morning, everybody. Hopefully you're ready for another one morning of chemistry with your host, you, Dr. White. Important announcement from the management, me, and that is this week, Tuesday and Thursday labs, I will be going through the practice set for Chapter 2, or practice problems Chapter 2. And I'll also go through the practice problems for Appendix A2, A4. And a week from this Friday is test number 1, and that allows me, I could have forced it for this Friday, but I want to have time because next week we'll do problem set for Chapter 3. That way I'll have plenty of time to study and be ready and do well on test number 1, which I hope you all do. All right, we're talking about Lewis structures, and Lewis structures deal with valence electrons. Remember, the material on Chapter 4 will be on test 2, and valence electrons, knowing what they are, is going to be on test 1. And a valence electron is the outermost electron of an atom. It's the most important one. That's the one, that's the one where the electrons, when you bring atoms together to form a chemical bond, in other words, to form this material, the paper, my skin, those are the electrons that form the bonds that you learn about this chapter that make up things you see all around you, which we call molecules. Anyways, last Friday I started the Lewis structure, and Lewis structure is a way, and sometimes called dot structure or Lewis dot structure. I like honoring Dr. Lewis who invented this, and calls it, as most chemists do, a Lewis structure. And there you show, for each element, you show each valence electron as a dot around the chemical symbol. And important thing, notice I have it in red, that is when you do a Lewis structure, there's one electron, that's a dot, on each side before you start pairing up and put a second one. And the maximum number of valence electrons is 8, so 4 sides, 2, 4, 6, 8. Oh, I remember that. All right, let's do some more practice. Here we have our periodic table, and the question would be, and let's look at the following. Question would be, sometime in the future, if you see it on a piece of paper like test 2 that I'd be handing out, you might see something like this Lewis structure 4. Oh, by the way, don't forget, this is a high-tech whiteboard and pens. I can change the font anytime. If you can't see it well enough, let me know. And also, I haven't said this at least since last Friday, everybody. Remember, in my class, actually in my lab, in my world, there's no such thing as a dumb question. Always feel comfortable asking questions in my class. All right, let's continue. And I'll do the first one. You know I'm going to share the fun. And the question is, how do you draw the Lewis structure for iodine? Well, first of all, you have to know its chemical symbol. Hopefully you've been practicing. You only have to learn 37. I'm not making you learn the whole periodic table. And now you have to find it. And this is a halogen, which means in this column, you look at the top, either a Roman numeral or the numeric value 7, and that tells you how many valence electrons. So we now know we have 7 valence electrons. Remember, I used the European 7, because I think it's cool. I learned that in German class in high school, for a German teacher from Germany. And now, how do you do this? This part you don't have to write down, but the following is how you do it. 1 dot for each valence electron, that's 4. You do 1 on each side before pairing up. I've got 4, I've got 3 more to go. I can start here, here, and here, and this would be 1. I could also do this, and I could do the dot, single dot on each of the 4 sides. The other 3 sides has 2 dots. Which is the right one? They're all the right one. And that's how you do it. Now, I'm going to let you have some fun on this one. Why don't you try to do the Lewis structure for nitrogen? For those who haven't learned, and should by now, but if you don't know, nitrogen is N, and here is the chemical symbol. Remember, when you're done, look up and smile. Ooh, it works. All right, it looks like everybody's done. Let's do this. Nitrogen, chemical symbol, N. You find it on the periodic table. It's right here. You look at the top. You either know the Roman numeral V is 5, or the number, like I have it written, is 5. So I have 5 valence electrons. The number on top tells you the number of valence electrons. And now, how do I write the Lewis structure? Draw or write the chemical symbol, like N for nitrogen. 4, 1 on each side first before you double up. Organic chemist, which I am, and that's type, and I'm biased, always puts the second dot on top. But if you wanted to do this, and it's going to look weird to me, but it's perfectly correct. Or one side has 2 dots and the other 3 has 1. And that's correct. Oh, let's do one more. Why don't you try calcium? And just in case you haven't learned, hopefully you have by now, calcium, which is an alkaline earth metal, is located right here. Chemical symbol Ca. I should mention this periodic table, each of the 4 tests in the final will be a copy of it stapled to the back of your test. So you'll always have this, and that's why I'm using this as opposed to this, or another one so you're familiar with it. All right, let's do it. How do we do the Lewis structure for calcium? Well, hopefully you've learned calcium, Ca. It's an alkaline earth metal, and it's right here. You look on top, 2 lines, Roman numeral, the same as the number 2. And now I have 2 valence electrons. This you don't have to put down, but this you do. And now I just go like this. Well, I'll start here. That's one way of doing it. And there are other ways. And what you have is the symbol, 2 sides have 1 dot, and the other 2 sides have no dots. And that's how you do valence electron. Chemistry isn't that hard. Time out for a commercial from Dr. White. Don't forget, you can always go to my YouTube channel, CHEMI 1105, to see lectures if you want to see it again. Instant replay. And I'm up to date. I've been pretty good on that. Hi, this is how we do Lewis structures, and these are the valence electrons. They're the most important ones of an element, in my personal opinion, because those are the electrons involved in forming molecules. What's a molecule? I'll teach you. Now, when we talk about chemical compounds, which everything you see here, the floor, my shirt, the plastic of the pen, the ink in this pen or marker, they're all chemical compounds, and there are two types. One type is called ionic compound, and the other has two names depending on what you like. It's either molecular or, I favor, covalent compounds. So there are two types of compounds. One is ionic, and the other is covalent or molecular, but I'll use covalent. Oh, I shouldn't ask this because it's on videotape, but I will. What the heck? How many of you are reading the book and bought the book? Raise your hand. Well, not good, but as you can tell, you're learning chemistry without spending money on that book. All right, so we have two types of compounds, ionic and covalent. And they exist in what we call, see, I told you I teach you what a molecule is, a molecule. I'll never ask on a test what a molecule is, and you people in the back have everybody in front of you as witness I said that. It's on videotape too. Ooh, I gotta be careful. Anyways, a molecule is a group of two or more atoms that function as a unit because the atoms are held tightly together. So a molecule is where you have atoms. Atoms are the smallest particle of any element that are held together, which I'll teach you what it is. Let's look at some molecules. You don't think of it, but water is H2O. And if you look at my water bottle here, there are lots and lots of molecules in here. You can't see them individually unless you're Superman or Superwoman or Supergirl. Anyways, with X-ray vision, I don't have any, but chemists have proved this is made up of water, H2O, which are molecules into here, lots of them. Another one, which is a molecule, sodium chloride, table salt. And that's sodium and chloride atoms held together in what we call a molecule. Let's see. Oh, another one. Later on, I'll teach a little organic chemistry at the end of the semester. A molecule that has 8 carbons and 10, oops, that's wrong. I'm getting it wrong. 8 carbons and 18 hydrogens. It's called octane, and that's a major component of gasoline. If you, next time you pass by a gas station, they're selling molecules. It's called gasoline. And part of the material, I'll teach you more about it, is octane. And that's why if you go into a gas station and look at the pump, it has the octane number. It was back about 1904, 1908, in that region when they first started to sell gasoline. Cars were pretty new. The best gasoline for those cars had the most octane in it, and that's how the octane number. So next time you're in a gas station with a friend, neighbor, or loved one, you can tell them, you know that gasoline contains molecule? No, don't. Friends don't like to hear chemistry in a gas station. So we have a molecule, and those are 2 or more atoms held together tightly in a unit. Now, what holds that together? It's the chemical bond. And a chemical bond are the attractive forces that hold atoms together in more complex units, which we call molecules. I'll never ask you what is a chemical bond in a test or other things like that. But I will use that term, and now you know what it means. And if we look here at water, how come in my water bottle here, all of a sudden, if you look at this, hold up. You see any hydrogen or oxygen atoms just floating away or coming apart? No, it holds together. How does it hold together? In a molecule chemical bond. The hydrogens or oxygens are held together by a chemical bond. Sodium chloride. If you put some table salt, which sodium chloride, table salt. I think I told you this if you ever go out to breakfast, lunch, or dinner with me, or brunch, and we're at a restaurant, I and other chemists will always, with other chemists around, ask, will you please pass the nickel? We don't say salt, we say nickel. Anyways, this sodium and chlorine is held together by a chemical bond. Now, I'm walking on a floor made of molecules that are held together by chemical bonds. My skin is made up of molecules held together by chemical bond. What's left of my hair, and my beard is still here, thank goodness, is held together by molecules held together by chemical bonds. So it's everywhere you look except the light, which is physics or chemistry. All right, there are two types of chemical bonds. Time for Dr. White to get subtle. Subtle. Two types of chemical bonds. The first one is called an ionic chemical bond. The second one is called a covalent chemical bond. So there are two types of chemical bonds, ionic and covalent. Now it turns out, and I'll teach you later in this chapter, next one, water is held together, the hydrogens and oxygen, by covalent bonds. And sodium chloride, table salt, is held together by ionic bonds. And while it's up here, this is also held together by covalent bonds. So different types of molecules have different types of ionic or covalent, or either have ionic or covalent. And it turns out Mother Nature, who's the greatest of all chemists, has molecules that have both ionic and covalent in it. I'm going to assume everybody in this room, and don't raise your hand if you didn't, in the last 24 hours washed your hands with soap. I hope you did. But anyways, next time you look at a bar of soap or the liquid in there, that material, which is molecules, is made up of both ionic and covalent bonds. And I'll teach you a little about that later on. By the way, how you get your hands clean with soap and water is high-level organic chemistry. I'll teach you that later in the semester. Way later. All right, what's an ionic bond? What's a covalent bond? An ionic bond results from the transfer, and it's important, one or more electrons from one atom or group of atoms to another atom or group of atoms. So, what's happening? You're transferring one or more electrons from one atom or group of atoms to another atom or group of atoms to form an ionic bond. And for this slide, this is active. Hint, you should know this. So on a test, if I ask what's an ionic bond, you should know it's a transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. So if I'm an atom and you're an atom, we're having an ionic bond, I'm going to say, here, I have an electron or so. Do you want it? Here, take it. Or you're going to give me your electron. We're going to form something that will form an ionic bond. Boy, that sounds great. But anyways, in real life, atoms do that. So an ionic bond, transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. And that's what we call ionic bond. Now, the other type of chemical bond is a covalent bond. Now, covalent bond is different from an ionic bond. How? It results from the sharing. Instead of transferring or accepting, it shares. I don't know when I started using this or doing this, sharing, like you're holding hands. Yeah, I still do it. But anyways, of one or more pairs of electrons between atoms. Remember, a pair means two. In case you didn't know, now you do. And therefore, a covalent bond, as opposed to ionic bond, you're sharing pairs of electrons. Ionic bonds, you can have one or more electrons being transferred, but a covalent is always sharing pairs of electrons. And if we look at water, then I'll teach you later this chapter, next chapter, part 2 of chapter 4, that the water, the hydrogens and oxygens are sharing electrons, I better do this, sharing electrons, and that's a covalent bond, or covalent bonds. And so, we have, that hint for this slide is active. And therefore, ionic, transfer of one or more electrons from one group of atoms to another, one atom or group of atoms to another atom or group of atoms, where a covalent bond is sharing one or more pairs of electrons between two atoms. Now, for both covalent and ionic bonds, there's something called the octet rule. I will never ask on a test what's an octet rule, but I'll hope you understand it, because that's the driving force for all of chemical bonds and why atoms either give up or accept electrons or share electrons. And that's the octet rule. How many of you have ever seen or heard a quartet? Music quartet? How many players are in a quartet? 4. Octet is 8. And in both ionic and covalent compounds, atoms tend to acquire the electron configuration of the nearest noble gas. So I won't ask you this, but let's take a look at the periodic table first. And if you look all the way to the right, left, right, the elements in this column are the noble gases. And if you look at the noble gas, how many valence electrons do they have? Look at the top and you'll see the number 8. And the noble gases, which used to be called, until somebody very cleverly found a way to make them react, they used to be called, from when I took chemistry in high school, college, even in grad school, they were always called the inert gases, and even a lot of times I'll still say that. But somebody found a way to react them. He won the Nobel Prize for that by beating it real hard in a chemical reaction. And now we call them the noble gases, but they're still the most stable elements. Why? Because they have 8 valence electrons, which is why we call it the octet rule. All the rest of the elements here want 8 valence electrons because that makes them stable. That makes them happy. You know atoms have feelings, don't you? Did you know that? No, they don't. But you can think of it as such. And that makes them stable. And Mother Nature has set up a system that atoms lose, gain, or share electrons to become very stable, which means they have 8 valence electrons, which is why it's called the octet rule. And again, this slide I'll never ask on a test, but the valence electrons, certain arrangements are the most stable. In other words, they just don't change spontaneously. You don't see me falling apart, my skin floating away, my hair, well, it did float, no, anyways, bad joke. But things are like when you came in the room, the floor is still here. When you leave, it should still be here. And that's because it's made up of stable molecules of stable atoms. And the most stable arrangement is N, which is a number, S2, which is the electron configuration, and NP6, 2 plus 6 is 8, and S and P shells and subshells are the outermost always of all atoms. And this is very stable because that's what the noble gases have. So we have this octet rule. And again, this slide I will never ask on a test. In the octet rule, when you make a compound, a molecule, water, sodium chloride, part of gasoline, whatever molecule you like to consider, atoms of the elements lose, gain, or share electrons in such a way that their electron configuration is identical to that of the nearest noble gas nearest to them in the periodic table. What that really means is, and notice I even highlighted in a pretty color, and that is you have atoms lose, gain, or share electrons to have 8 valence electrons, octet. So where does this leave us? Well, let's talk about, in ionic compounds, we have something called ions. And ions, when you transfer one or more, you form an ion. When an element loses one or more electrons, an ion with a positive charge is formed. And this is called a cation. I'll never ask on a test what is a cation or a positive ion or an ion, but I'll ask you to know how to figure out what different elements form. Let's look at magnesium. And say sometime in the future, just two, you see on test 3 points each, what ion does the following element form? Well, how do you do that? And I would write out magnesium, because you have to know the chemical symbol, but in case you haven't learned it, I'm going to help you out today. And how do we do that? Well, if we look at magnesium, and I'll come over here so I don't have to switch back and forth. Magnesium has an atomic number of 12. That means it has 12 electrons and 12 protons. And I will need the periodic table. Now, here's magnesium. And magnesium has atomic number of 12, 12 protons, 12 electrons. Remember, the atomic number tells you the number of electrons and protons. And now the question is, What ion does it form? Well, it wants to have an octet, the same as the nearest noble gas. How do you define nearest? The one with the closest atomic number. You got two choices. Here's magnesium. It could be argon. Let me straighten this out so you don't get, I feel better. At 18, and you have neon at 10. Those are the two closest noble gases. Which one is closer numerically? Time's up. Hopefully you pick 10, because that's only 2 away, where argon at 18, 18 minus 12, is 6 away. So you look for the closest one numerically. Let me do that again in slow motion. You look at the atomic number. Then you say which noble gas is nearest numerically based on atomic number. And now I have two choices, argon at 18, or if I go backwards, which is really not going backwards, neon at 10. Which is closer numerically? Subtract. One is 2 away, the other 6, which is a smaller number. Hopefully I'll pick 2. So, what does that mean? You never lose protons, but an atom can either gain or lose electrons, or share them. In this case, we're looking at gaining or losing. And what's the nearest noble gas? Neon. How many electrons does neon have? You look at the atomic number. The atomic number tells you how many electrons? 10. All right, now what do you do next? Each electron has a -1 charge. If I do the math, it's -10. Each proton has a +1 charge. There are 12 of them. And now you add this together. And if you add +12 plus -10, you get a +2. That tells you there's going to be a plus charge that's 2. How do you show that? By writing the ion. You write the chemical symbol, superscript. Now there are 2 ways of doing it. I'm old school, yes, I still have. When I learned, we always did it this way. About 10, 15 years ago, chemists started doing it also another way. Putting the number first and then the plus. Either one is correct on the test. And this tells you that magnesium forms a +2 cation. It's got a positive charge, and that charge is 2. And we'll learn later on, knowing that charge is important. Let's do another one. I'll let you try this one. Why don't you try that one? What would be the charge? What ion would be formed? What do you write for calcium? And calcium, in case I didn't even write it out, in case you don't know where it is, time for a little help from Dr. White, right there. Why don't you try that one? What's the nearest noble gas? And then find out how many electrons and protons this has, 20. And look at the nearest noble gas. And you try. should have done another example before I threw you off the deep end. So, let's see, people are still working, so we need some time to finish. All right, looks like everybody's done. Let's take a look at this. First thing you have to know is how many protons and electrons calcium has. How do you figure that out? Atomic number, 20. That tells you how many protons and electrons. Now, what is the nearest noble gas to calcium? You have two choices. End of this row, krypton, which is 16 away, or you can back up to argon, which is 2 away, which is a smaller number, 2 or 16. I'll pick 2. And therefore, calcium, you never change the protons. They always come along for a ride, but you can't give up or gain electrons. Calcium is at 20, it wants to go to argon at 18. How many electrons does argon have, or if calcium lost it? It would be 18. Now you do the math. Each electron is a -1 charge. Each proton is a +1 charge. Do the math, -18 plus 20. If I add this together, I'll have a +2. And now, how do you write that? Calcium +2 charge, or you could have written it, I like this way, but you can do either one. And that's how you do it. We'll do some more. Now, one of the questions you should always ask in my classes, I'm learning this stuff. Well, the obvious answer is someone told you you need this class for the program you want to get into, or a degree, and therefore you want a good grade. Well, why learn this stuff? Well, how many of you have heard calcium? You should take it for strong bones. Well, they're not talking about calcium, the element, because the element calcium is a metal like this pipe. Are you going to chew on this pipe to get stuff for your body? No, you break your teeth, which is not a good thing, I'll bet. But what do you really need for strong bones? Not calcium metal, but the calcium cation. This is what helps make strong bones. So why are you learning about? Well, if you like to be able to stand up straight and have strong bones, which I do, I take a calcium supplement, and this is what you take in a molecule that's ionic, and that's how your body gets calcium. Whenever you buy a bottle of milk or other products that says fortified with calcium, no, they're not putting in calcium metal, they're putting in calcium cations. Now, another important lesson I want to teach you, once you know one element in a column is what ion it forms, you know all of them. And if you notice, I picked calcium for a reason. Magnesium we learned was a +2. Ooh, that's a +2. And the others, which I haven't asked you to learn, those are all +2. And so once you know one in the column, you know them all. Let's try one more. On a test, I'd write it out, sodium, but today I will write the chemical symbol, and the question is, write the ion sodium forms. In case you don't know, sodium is an alkali metal. It's found right there, so why don't you try that? I'm being mean today to make me think. Remember, if you came in late, don't forget to sign in at the end of the class. All right, I think everybody's done, so I'll go ahead and do this. All right, here's sodium. How many electrons and protons? Look at the atomic number. And sodium now, it wants to have the same number of valence electrons, 8, which is why it's called the octet rule. And what's the closest noble gas to sodium? You have two choices. All the way here, argon is at 18, or neon is at 10. Which is closer numerically? One's 1 away, the other is 7 away, which is a smaller number, and hopefully I'll pick 1. And therefore, it wants to have the same number of electrons as neon. How many electrons does neon have? Look at the atomic number, it's 10, and that tells you sodium wants to have 10 electrons. You don't change the number of protons. If you find a way to do that easily, let me know, and we'll be rich beyond my wildest dreams. That goes beyond my own Ferrari, Lamborghini, island in the South Pacific, and fighter jets. Yeah, I'd like a fighter jet, not really. Anyways, beyond that, it can't be done. So, what do we do next? You know, each electron is a -1 charge. Each proton is a +1 charge. And now do the math. -1 times 10 is -10. +1 times 11 is +11. Add them together and you get a +1. When it's a +1, you don't show the number, you show a plus sign. And how do we write that ion? Like that. And that's how you write the ion for sodium. Now, how many of you have heard keep your sodium level down so you can control your blood pressure? When you get older, your doctor, if you have too much salt in your diet, will say, or how many of you heard keep your salt level down in your diet to control your blood pressure? Well, I remember years ago when I went in for my physical at a new doctor, and he was a great doctor, and the doctor called me and said, I need to talk to you, we got all your results in. And this doctor is very honest and direct, which I like in a doctor. And he sat down and we're talking, and he says, I got your test results, and do you want to be alive in 5 years? This was 5 years ago, and I said, sure I do. He said, well, one of the things you got to do is get your sodium level down. And what he was talking about was not sodium metal. Sodium metal is something that will burn in water. You never want to consume sodium metal because you'll be in the hospital or dead. What we're talking about is sodium cations, which you get from salt mainly. And if it's too high, that will affect your blood pressure, and that's a bad thing. And I've kept my sodium level down, and lo and behold, I'm still alive, which is a good thing. Now, you can have positive ions where, if you notice a positive ion, the element loses electrons. And you can also have negative ions. And negative ions are where an element gains 1 or more electrons. I'll never ask you what's a negative ion, but I'll ask you to know how to figure it. And it's an ion with a negative charge that's formed. It's also called an anion. How many of you have heard the term anode? Like one side, I don't think you teach anything in school. One side of a battery is called an anode, negative. The other is cathode, from anion and cation. Anyways, how do you figure that out? Let's look at chlorine. And the same question would be, and I'd write out chlorine, that could be a chemical symbol, but what ion does chlorine form? And let's take a look at that. Good news, you already know how to do this, sort of. All right, let's look at chlorine. Chlorine, halogen. How many electrons and protons does chlorine have? Look at the atomic number. And if you look here, you'll see 17. So it has 17 electrons, 17 protons. Now, what's the nearest noble gas? It's a hard one. You got three choices. Argon, 1 away, neon, 17, and krypton, a lot away. Which is the closest? Hopefully I'll pick 1 away, and that would be argon. Now, the chlorine ion will still have 17 protons, but it will have the same number of electrons because it wants its octet to be stable. I'll be with you in a second. Is there a question? Yes, questions. You got a question?
How are you knowing it's like argon or neon? Like I don't.
Got to talk a little louder. I didn't have a miracle, so my hearing hasn't improved.
How are you knowing it's like argon or neon? Like,
All right, that's a good question. Ask. Always feel comfortable asking. And let's find out. All right. You all agree that's chlorine, which you are interested in. And the thing you have to find out is what's the nearest noble gas? Why? Because noble gases have the most stable electron configuration, 8 valence electrons. So it wants to have 8. So how can it get 8? It can get 1 electron, have the same as argon. It can lose 7, have the same as neon. Or it could gain a lot and have krypton. Now, which one is the closest? Oh, I saw the light bulb go on top of your head. You're getting the hang of it, right? Which is the closest numerically? Argon, because it's only 1 away. Now, if you understand how to find, you'll do good on test too, which is a good thing. All right, back again. Chlorine wants to get the same number of electrons, an octet, as argon, and that's 18 electrons. And now, don't forget, you don't change protons. Every electron is a -1. Every proton is a +1. You do the math, add this up, you get a wrong thing, right thing. And how do you show a -1 charge? The symbol superscript minus. And this is the ion chlorine will always form when it forms an ion. And this is how you do ions. I'm going to let you out a little 35, 40 seconds early.